So now we're going to talk about the remainder theorem and the factor theorem. The main thing that these talk about is if you have if you're doing some synthetic division, you come up with a remainder of 0. That means that term is a factor. From there, you'll want to factor again as many times as you can until you get all of the factors. So that's what we're going to be working on here. So we're trying to determine whether this is a factor of the polynomial. So use synthetic division, find that the remainder is 0. So since the remainder is 0, x plus 3 is a factor. So you take the quotient, whatever's left. Yeah, the quotient. You take the quotient, write it out, see if you can factor it again, to see if you can come out with all of the factors. So for this one here, we're going to use synthetic division. So you bring down the 1, then we multiply. -1 times 1 is -1. Add -4 plus -1 is -5. Multiply. -1 times -5 is 5. Add -6 plus 5 is -1. -1 times -1 is a positive 1. 4 plus 1 is 5. Multiply. -1 times 5 is -5. 5 plus -5 is 0. So since the remainder is 0, x plus 1 is a factor. So now we take the quotient, whatever's left. Since we started to the fourth, ours is going to be cubed to start with. X cubed minus 5x squared minus x plus 5. Now we can factor this by grouping. So we have to take what we had, x cubed minus 5x squared minus x plus 5. Set up our groups. So I have x cubed minus 5x squared, and then negative 5x plus 5. Factor out what we can. So that's an x squared. We're left with x minus 5. Factor out what we can over here. We'll want to pull out, this is supposed to be just a regular x there. Here we'll want to pull out a -1, so that we're left with positive x minus 5. So then we're left with x squared minus 1, x minus 5. Now x squared minus 1 is actually a difference of squares. So we'll be able to factor that even further to become x plus 1, x minus 1. And we still have that x minus 5, and then our original factor, which was x plus 1. Okay, so we're trying to determine whether this is a factor. So we take our term here, do the opposite sign, so -4. Take our coefficients, 2, 8, 0, 2, and 8. Our line, bring down the 2, multiply. -4 times 2 is -8. 8 plus -8 is 0. -4 times 0 is 0. Adding 0 plus 0 is 0. Multiply. -4 times 0 is 0. 2 plus 0 is 2. Multiply. -4 times 2 is -8. 8 plus -8 is 0. So yes, it is a factor. So now we want to check for the remaining factors. Our original function was to the fourth, so ours will be cubed. So 2x cubed plus 0x squared plus 0x plus 2, which will get us 2x cubed plus 2. Can factor out a 2, get x cubed plus 1. X cubed plus 1 is a sum of cubes, because x cubed is the quantity x cubed. 1 is 1 cubed. So that'll get us x plus 1, x squared minus x plus 1, and then our original factor, which was x plus 4. So this whole thing is our factor there. Okay, we're trying to check if this one is a factor, so we take our a value, which is a positive 1, opposite sign. We take our coefficients here, 3, 0, -2, 5. Bring down the 3, then we multiply. 1 times 3 is 3. 0 plus 3 is 3. Multiply. 1 times 3 is 3. -2 plus 3 is 1. Multiply. 1 times 1 is 1. 5 plus 1 is 6. So our remainder is not 0, so it is not a factor. So long division and synthetic division, it's essentially the same process. It just saves a ton of space. You don't have to bring all of those values down each time because it's all being nested in there. How does knowing one linear factor of a polynomial help to find the other factors? Can use division to find the product of the other factors. Which may then be factorable. We're always trying to factor as much as we possibly can. What conditions must be met in order to use synthetic division? We must have a linear binomial with coefficient of 1. Linear, so the x is to the first power. Binomial means we have two terms. The value in front of the x has to be 1. So essentially we have to have x plus or minus some number a. And how do we know when the divisor is a factor of the dividend? When the remainder is 0.